The estimated labor and material cost to install a ground rod is $600. The material breakdown is as follows. Firstly, a 3/4 inch by 10-foot ground rod costs $35. Secondly, an 8-foot ground clamp is $15. Thirdly, miscellaneous items amount to $20. The labor component is based on 3 hours at a rate of $175 per hour, totaling $530. This yields a total cost of $600. Please be aware that actual costs may vary depending on factors such as the specific site conditions, the complexity of the installation, and local pricing for materials and labor. Grounding is a critical safety component of an electrical system, and a ground rod provides a path for fault current to safely dissipate into the earth. This helps to protect people from electrical shock and to prevent damage to equipment. When installing a ground rod, there are several important considerations. Firstly, the location of the ground rod should be carefully selected. It should be placed in an area where the soil is moist and conductive, and it should be protected from physical damage. Avoid areas where the ground may freeze deeply, as this can reduce the effectiveness of the ground rod. Also, it should be placed where it is accessible for inspection and maintenance. Secondly, the ground rod must be driven deep enough into the ground to provide adequate grounding. The National Electrical Code, or NEC, specifies that a ground rod must be at least 8 feet long and must be driven into the ground so that at least 8 feet of it is in contact with the soil. In some cases, it may be necessary to install multiple ground rods to achieve the required grounding resistance. Thirdly, the connection between the ground rod and the grounding electrode conductor must be secure and corrosion resistant. A ground clamp is typically used to make this connection, and it should be made of a material that is compatible with both the ground rod and the grounding electrode conductor. The connection should be tightened securely to ensure a good electrical connection. The grounding electrode conductor, typically copper wire, connects the ground rod to the main electrical panel. Its size is determined by an NEC table 250.66 based on the size of the service entrance conductors. It is essential to consult the NEC and local electrical codes for specific requirements related to grounding. These codes provide detailed information on the proper installation of ground rods and other grounding components. Proper grounding is crucial for electrical safety. A properly installed ground rod provides a low impedance path for fault currents, helping to protect against electrical shock and equipment damage. It's important to use the correct materials and installation techniques, adhering to the NEC and local regulations. When dealing with electrical work, it is always recommended to hire a qualified and licensed electrician. Electrical work can be dangerous, and a professional electrician has the knowledge and experience to perform the work safely and correctly. They will also be familiar with local electrical codes and regulations. The price of $600 is an average. To determine a fair price for installing a ground rod, firstly assess the specific requirements of the installation. Consider the local soil conditions, the accessibility of the grounding location, and any potential challenges that may arise during the installation process. Secondly, obtain quotes from multiple licensed electricians in the area. This will provide a better understanding of the prevailing market rates for this type of work. Be sure to ask for a detailed breakdown of the costs, including the cost of materials and the labor rate. Thirdly, factor in the cost of materials. The price of ground rods, clamps, and other grounding components can vary depending on the supplier and the quality of the materials. Obtain quotes from local electrical supply houses to get an accurate estimate of the material costs. Fourthly, estimate the labor time required for the installation. This will depend on the complexity of the installation and the experience of the electrician. A simple ground rod installation may only take a few hours, while a more complex installation may take longer. Fifthly, consider any additional costs that may be associated with the installation. This may include permits, inspections, and any necessary repairs to the existing electrical system. Electrical permits are usually required for grounding installations, so factor in the cost of obtaining the necessary permits. Sixthly, compare the quotes from different electricians and choose the one that offers the best value for the money. Don't necessarily choose the lowest quote, as this may indicate that the electrician is cutting corners or using substandard materials. Choose an electrician who is licensed, insured, and has a good reputation. Seventhly, ensure that the installation complies with all applicable electrical codes and regulations. This is essential for ensuring the safety of the electrical system and preventing potential problems in the future. A licensed electrician will be familiar with these codes and regulations and will ensure that the installation meets all requirements. Remember that safety is paramount when dealing with electricity. If you are not comfortable performing the work yourself, hire a qualified and licensed electrician to do it for you. A grounding system's effectiveness can be tested using a ground resistance meter. These instruments measure the resistance between the grounding electrode and earth. The NEC generally requires a resistance to ground of 25 ohms or less. If the resistance exceeds this value, an additional ground rod may be required. The size of the grounding electrode conductor is determined by NEC Table 250.66, based on the size of the service entrance conductors. This conductor connects the ground rod to the main electrical panel, providing a path for fault current to return to the source. The type of ground rod is also important. Common materials include copper, copper-clad steel, and galvanized steel. Copper and copper-clad steel offer excellent corrosion resistance and conductivity. The NEC specifies minimum sizes and materials for ground rods, ensuring they can effectively carry fault current. Periodic inspection of the grounding system is recommended to ensure its continued effectiveness. Check for corrosion on the ground rod, clamp, and grounding electrode conductor. Tighten any loose connections and replace any damaged components. Soil conditions can affect the resistance of the grounding system. Dry or sandy soil may have higher resistance than moist clay soil. In areas with poor soil conductivity, multiple ground rods may be required to achieve the desired resistance. The distance between ground rods is typically at least twice the length of the rod. This spacing helps to minimize the overlap of their effective grounding zones. The depth of the ground rod is also critical. The NEC requires that the ground rod be driven at least 8 feet into the ground, with the top of the rod at or below ground level. This ensures that the rod is in contact with the earth's moisture, providing a reliable grounding path. When installing a ground rod near underground utilities, it's essential to call before you dig. This will help to prevent damage to underground pipes and cables. The location of underground utilities can be marked, ensuring that the ground rod is installed safely. The grounding system should be properly bonded to other metallic components in the electrical system. This includes water pipes, gas pipes, and metal building frames. Bonding helps to create a common ground potential, reducing the risk of electrical shock. The NEC provides detailed requirements for bonding these metallic components. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This helps to trip the circuit breaker or fuse, interrupting the flow of electricity and preventing electrical shock. A properly grounded electrical system is essential for safety. Grounding is not the same as bonding. Grounding provides a path for fault current to return to the source, while bonding connects metallic components to create common ground potential. Both grounding and bonding are important for electrical safety. The neutral conductor is also connected to ground at the service entrance. This connection helps to stabilize the voltage and provide a path for neutral current to return to the source. The NEC specifies the requirements for grounding the neutral conductor. Ground fault circuit interrupters or GFCIs are another important safety device. GFCIs detect small imbalances in the current flow and quickly interrupt the circuit, preventing electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Surge protection devices or SPD can help to protect electrical equipment from voltage surges. SPD divert excess voltage to ground, preventing damage to sensitive electronics. SPD are often installed at the service entrance and at individual pieces of equipment. Electrical codes are constantly evolving to improve safety. It's important to stay up to date on the latest codes and regulations. The NEC is updated every 3 years, and local electrical codes may also have their own requirements. Working with electricity can be dangerous. Always follow safe work practices and wear appropriate personal protective equipment. If you are not comfortable performing electrical work, hire a qualified and licensed electrician. A ground rod should be installed according to the manufacturer's instructions. Read and follow the instructions to ensure a safe and effective installation. A ground rod should be driven into the ground vertically, if possible. If obstructions prevent vertical installation, the ground rod can be driven at an angle not more than 45 degrees from vertical. The area around the ground rod should be free of debris and vegetation. This will help to prevent corrosion and ensure a good electrical connection. The ground rod clamp should be made of corrosion-resistant material. Copper or bronze clamps are typically used. The clamp should be sized appropriately for the ground rod and the grounding electrode conductor. The grounding electrode conductor should be continuous and unbroken. Splices are not permitted in the grounding electrode conductor. The grounding electrode conductor should be protected from physical damage. It can be run in conduit or protected by other means. The grounding electrode conductor should be connected to the main electrical panel at the grounding bus. The grounding bus is a metal bar that is used to connect all of the grounding conductors together. The grounding system should be inspected periodically to ensure that it is in good condition. Check for corrosion, loose connections, and physical damage. Repair or replace any damaged components. If you are unsure about any aspect of grounding, consult with a qualified and licensed electrician. They can provide expert advice and ensure that the grounding system is installed correctly. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified and licensed electrician before performing any electrical work. The electrician can assess the specific requirements of the installation and ensure that the work is performed safely and correctly. The cost of installing a ground rod can vary depending on the location, the complexity of the installation, and the electrician's rates. Get multiple quotes from different electricians to compare prices. Be sure to ask for a detailed breakdown of the costs, including the cost of materials and the labor rate. When choosing an electrician, be sure to check their qualifications and experience. Make sure they are licensed and insured. Ask for references and check their online reviews. It is very important to work with a qualified and licensed electrician to ensure that the electrical work is performed safely and correctly.